Hi, everybody. I am Kevin Miller. I am one of the instructors at Epic Games. I generally teach people how to use Unreal Engine for film studios and that sort of thing. I am going to go at lightning speed a little bit on this because it's going to be like an hour-long deal for this. So if you want to get out a recording device, go right ahead and take pictures so you can come back to it later as I talk a mile a minute. Next to me is my human mic stand, Bun. You'll see him on camera a little bit, so I'm going to pass it off to him as we kind of jump right through here. We're going to start out with our slide deck, which you can kind of see right up on here. First, that's not me, that's Sean. He's going to be handing out some stuff tomorrow. He's going to be helping us with this quick start. We split it up into two parts. I'm going to handle everything today because we are a little short on time, and I'm going to try and make it up. That's me. I am actually going to give you this, and as we get started, we're going to talk about some key technologies here for ICVFX. So I'm going to sit down for a minute and run through these really quick and get everything ready. All right, so as we start out, there are some key technologies that you kind of worked in order to get an LED wall and get things up and running. Hardware stages and volumes that you're going to typically work with. At Epic Games, we are on the NAND stage. So if you see a large volume like this, the NAND stage over in El Segundo, that is a 50-foot wall. Basically, it is ginormous. If you ever stand in one of these things, they are amazing. Right next to it on the same location is the LA Lab. It is our R&D stage. It is also located in El Segundo in the same space. It is a slightly smaller one, but that is mostly where everything that we do at Epic Games to test and put together our stage actually takes place. Next to that is a really tiny space. It's about the same size as as what you're seeing right here. That is our former latte stage in our old Culver location. We put that out to pasture, took it up to a farm. It's going and running free right now inside upstate somewhere. So I promise it's still living. All right, so things to consider as you go through LED walls for volumes. The LED wall volume considerations. Your configuration here, you want to make sure you're going to work with either a flat configuration. Those have limitations, so be aware of like how to light them. Notice we have a ton of lights in here today, so flat wall configurations do need to be worried about that, so you get reflections, bounce, things you're going to get that are going to show up on camera. Make sure you got heavy backlight, limited environment reflections that are in here. And then for a curve configuration, these are mostly cylindrical, and they do have really unique acoustic issues. I hadn't experienced this until about a month ago, where if you're standing out on the stage and you hear somebody talking that's close to the wall, you can actually pick up everything that's being said off the wall due to like specific acoustic reflections, which is kind of funny and cool. But if you're trying to have a private conversation, not necessarily really good for that. Now, typically some of that can be mitigated a little bit with a U or oval shape. And then you need plug-in walls for that full 360 coverage when you're building your stage. Oh, I've got one. Thank you. As you go through here, here's some other things to consider as you go through and build a location if you're going to build a wall space for this. LED wall considerations are clear spans for all of this kind of stuff. Ceiling heights, weight capacity, concrete floors, whether or not you're going to use those. It's really important if you do have them, so you have a nice stable level location. Otherwise, you'll run into issues. Air conditioning, really important. It's a little hot outside. It's sometimes hot inside the convention hall. Imagine doing that, but then having a lot of heat coming from these. If you get a chance to walk up or get near to these panels, you will feel the heat. They are warm. Office and storage space, mill space, parking. Parking is important because you're going to have crew, stages, sets, people, actors, all that stuff show up. You're going to need a place to put them. So, looking at our hardware, really quick, here's a big diagram that you're going to have for your wiring. This is a more complicated wiring diagram. As we look through this diagram, you can kind of see how your stage is configured, where you want to have your wiring, your cabling, everything else that gets connected in here, where your control room and control centers are, how you handle audio in all those locations. This is really complicated. Again, if you want to take a picture of this and refer to it later, here you go. It's right here. But it is also in our virtual production guide, so you can find that there as well. Here's a more simplified version, something that you're going to see a little bit like in here, where our hardware configuration shows our camera, video distribution, our mocap network for time lock, gen code, everything that we're going to be running in here. The gen lock time code, other way around. All that's going to be running in through our two control cards out to our render node, even into our box that is separated for our motive or Moses or whatever our tracking system is going to be using. And then right through here, it gets distributed out to a processor and then right into LED walls that are going to be working through here. So sometimes we use Brompton distribution and send out to our row panels. Now today, if you're looking at the wall that we're working with today, we are actually working with the row black pearl 2 panels that you see up on the wall. The big stage is made up all of those. They're 500 millimeters by 50 centimeters, or basically 50 centimeters squared. They have a pixel resolution of 176 pixels squared and a pixel pitch of about 2.8 millimeters. The LED panels that you're going to see over here is a configuration of basically 8 panels side by side. They are 600 millimeter by 1200 millimeters. They are 104 by 208, and they are stacked and put out there. The pixel pitch on these is a lot wider. It's 5.77 millimeters. And these are also the row CV5 RGBW panels. Now, as we have them laid out, there are some specifics for our wall specs, and this is going to be important as we start building things. So as you build through your wall specs, typically you've got a 12 by 7 panels, and then we have our 4 by 2 panels. Knowing the spaces is going to give you the dimensions that you're looking for and the number of pixels that we build out as we move into nDisplay to build this together. So right now we're working with a total resolution of 2112 pixels by 1232 pixels. And then our wild wall, our side wall, is a 416 square pixel set. Now our tracking offset origin, I didn't actually get this number in here. It's about 300 centimeters inside, or 300 Unreal units as we go into the engine to work through that. And as we work through for our processing, basically you want to make sure that you place on your processor the pixel layout that you're actually going to have for whatever your stage is going to look at. Now our pixel image is going to look a little bit different than what we actually have up on this when we do transact, because we are laid out a little bit differently. This example that I'm showing you here is the layout for the formerly active LA training stage that Epic Games had. This is our latte stage. And as you can see, processing works in a flow like this. So what you have for your pixel resolution on a monitor, like what you see me standing in front of here, is typically what's going to be projected and mapped out through your pixel feed. So your processor mapping must match what you have on your layout for your feed, because what's in these two little rainbow corners here is what's going to actually be projected to the walls. As you go through here, we got to get ready and we go in to prepare our document in here. So we're going to jump right into and go through our project setup. There are some things that you're going to run into if you're not familiar with some of the terminology that we use. Terminology that we use here is NDC. We just abbreviate this. This is for our nDisplay configuration. And then we also have cluster. Cluster is a group of PC hosts, and as you can read through all of this kind of stuff, we have a host, node, viewports, frustrum, and then pixel processors that we just talked about. I know it might be a little bit confusing, but as I said before, if you want to record this as you go right ahead and kind of come back and slow me down at half speed through one of those VLC programs. That way you can kind of catch everything that I've said. So as we go through here, you have your nodes, your viewport, your frustrum. That's all for your camera pixel processor. And as we get that set up, you will see me using my nDisplay configuration to actually show how these components get set up. Now, for ICVFX, there are a number of plugins that you're going to need to have enabled to use in here. We typically recommend enabling all of these. Anything that you see in green here, these all work. Now, our labs, we do use OptiTrack Motive. We have a plugin that we make active for those. Today, we are using Moses on this location, so Moses plugins should be active in the engine as well when working with this. That way, you can do all of your tracking in the engine here as well. Might want to also take a picture of this if you're not entirely sure what's going on or what they are. Again, these are all the plugins that we recommend using for ICVFX virtual production. All right, so before you get started, you are going to need geometry. Anytime you have a customly configured stage like this, you're going to need an actual custom geometry configuration that you're going to want to build either in Maya, in Blender, or in 3ds Max. Any DCC that will generate panels the way that you want, that will let you curve them so that they are uniform, and let you UV unwrap them. Now, typically your first channel for your UVs, you want to make sure that these are a full covering the entire space, non-uniform scaled UV set. This calculates the projection setting for the mesh onto the walls. So as this gets put out for your projection settings, anything that fills in this UV set is going to be put into this space. Your second UV channel 1, This supports key tracking, markers, chroma key, any of that information that you're going to put in here. You need to have these be uniform and evenly spaced out. The important part here is that each of your panels represents a space. So when I set this up to look like this, in my UV space, we'll look at our UVs for our geometry. Our UVs should be laid out so that our UV channel 1 matches the square space of the panel. So if I was looking at this wall and it was turned off and I could see the individual panels, that is what my UV space and that is what my UV set should look like. For my non-uniform version, they can stretch. That's fine because it'll get compressed when it gets put into the stage. It's going to fit in the space that sits there. Now, we are ready to kind of jump into Unreal Engine and take a look at Switchboard and everything else. So as we get started, we can kind of switch over to Unreal Engine, and I'm going to demo into that. So we're going to start out with nDisplay, and you're kind of wondering to yourselves, what is nDisplay? Well, nDisplay is a configuration tool, and it's right over in here. And to create an nDisplay configuration, typically what you do is you go in and you just right-click in the Unreal Engine. And I'm sorry for the feedback that's on here. Let's see if we can get a tiny bit away. It's still here. Basically what you can do is, I'm sorry, you're doing a really great job holding all that. You just random clear, you're going to see that there's an nDisplay option. When you go in and create an nDisplay configuration, and we can copy an existing configuration, which we've got right in here, or create a brand new one. And I'm going to walk you through the steps to create a brand new one, but as you can see, I've already got one that's already finished in order to save some time and get us up on the wall. So you just kind of click through, create a new configuration, and click Finish. Then once you're done for naming it, I actually recommend naming things NDC for nDisplay configuration, and then naming it whatever you're going to work through so you know what you're working with. Naming conventions are going to be easy and helpful because Unreal Engine does have a bit of a character limit in what you're going to be putting up. Now you can keep that pretty long, but eventually you're going to run out of a character string limit, and it's going to bark at you a little bit. Excuse me for just a second while I take a drink of water and a big breath. I know that's a lot.
Water's not good for you.
It is not. And if you're wondering, I'm drinking lemon hint water to help me out. So now that I've plugged that as well, let's move on to the next set here. So as I name my convention in here, I'm just going to call this one SIG for SIGGRAPH, or I call this ACM, and I'm just going to name it for 23 for the year, because that's what we're going to do. Go ahead and hit that. Now, typically looking at the nDisplay configuration, this is the configuration that you're going to see and want to work with. So your configuration looks like this. There are several panels that you're going to run to in your configuration, and your configuration has your components that are added in here. And it also has in a cluster section, as well as a details panel, an output mapping, and in here a special preview. Now, if you're working with other geometry, which I recommend doing if you're building your own stage, you can go right ahead and delete this and replace it. But if you're working at home, and doing nDisplay configuration using a single node like this, you can actually use this monitor that you're working with. Hey, if you got televisions, they work too. You have the options of choosing specific aspect ratios. So if for some reason you have a CRT monitor that still has that nice 4:3 aspect ratio, you can go ahead and use that as well. We have that built into the engine. Choose those, whatever configuration fits. So as we go through here to get started, typically I'm just going to go ahead and start by deleting this. Delete. There we go. And I'm going to need some geometry. Now the geometry is typically located here in our geometry section. For my example, I'm going to grab meshes that I've already laid out, and you can see I've already imported those. When you first start out, you're going to want to build your geometry, save it as an FBX, and then go ahead and import by clicking on the folder that is in location for here, and adding in that geometry. You've got this nice little import to game stage location, and that's where you're going to import that information. Keep all your settings the same. Your FBX import works as pretty standard, and once that importing is done, you're ready to go. Now your geometry, as we open it up, as I mentioned here, it's going to come in like this. It's going to bring in a shader. It's going to bring all this information you're going to look at, and you're going to want to check your UV sets. UV channel 0, as I mentioned, is laid out just like this, and that looks like that's for our big wall here. That is our layout. UV channel 1, on the other hand, looks just like this. So it is laid out, everything is square and uniform. It gives me my 12 panels across and my 7 panels high. Each square represents a panel. It's actually really handy to make sure that each panel individually lines up this way. That way you know what your configuration is and you know exactly which section of each pixel is going to go where. Now, if I go over to my other side, my wild wall, and I take a look at this, you're going to see something very similar. Because I also want to check my UV channels in here, and these are laid out to match the panels that are in here. Now, one thing to note is I didn't quite know what the configuration was going to be like when I got here. So my configuration, my panels, are the panels 4 vertical or 4? I think my panels are reversed. I'm guessing, but I think my panels are reversed. So I would have to go in and edit my UV channels to make them work this way. Otherwise, everything's going to be rotated 90 degrees. So my UV channel 1 matches this. Now, the reason that it matches this is because the actual space of my uniform geometry, my panels are rectangular. So if I have rectangular panels, these panels have to match my UV set. They should match what's going on here. So I have the right number of faces that matches my panels again. Again, I want to reiterate that because it's really important and helpful when laying things out. Now that I have my geometry, I'm going to go ahead and bring that in, and I need to create some nodes in here. So first thing I'm going to do is I'm going to add in a transform node. So this is an nDisplay transform. Just go ahead and add that. And I like to just call these X-form. If I need more of them, I enumerate them 0, 1, 0, 2, and it gives me my location. This allows me to move my panel set around once I have them ready to go. Now, the reason that you can see me move this down into the smaller space is that to add in our geometry, you need to click and drag all of our geometry in here right up into our X-form. That's going to place our geometry based on the location that is in here. It's also going to allow me to create the offset that's in here. Now, if I were to look at the actual FBX files or the Maya file that I used to create these, you would see that my geometry is offset from my origin position. Now, knowing that my origin is actually in the bottom corner here on our stage, I would actually go ahead and grab my X-form and move this over so that my geometry is now in that position. And because I have my X-form, my transform allows me to make that adjustment based on that location and make the adjustment for my position. So now my origin position is in my correct location, and I need to start adding in some things. If I'm going to do any kind of camera work, I'm going to go right up to this main node. I'm going to go ahead and add, and right down here is an ICVFX camera. Now, the ICVFX camera, you can go ahead and name to match whatever your camera is that we're going to be using. Since I believe that these are the Sony Venice, I'm just going to go ahead and go to Sony. And I'm going to go V for Venice, and I'm going to call this ICVFX cam. That way I know that this is a Sony camera, and it matches to what I'm going to go when I actually build out the other camera. This way I can also add in additional multiple cameras because we do support multiple cameras to be able to switch between them inside this multi-frustum object. One thing you'll note is that when I'm ready to compile in here and I have my cluster nodes, you'll see my frustum show up, and you can see that the position here for my camera is not in the same position as my object. That tells me that I also need to make a rotation. So I need to rotate this 90 degrees, land negative 90 degrees, and then readjust the position of my origin. So once that's really set to where we're going to go, then I need to go ahead and grab my camera. And I'm going to move this into place so that I can kind of see that when it's ready to go as well. This way, when I have my frustum enabled, it should show up on my screen when I have my objects ready to go. So next thing I need to do is I need to start creating clusters. So if I go into clusters in here, I'm going to go ahead and add in a new cluster node. And for this, I'm just going to use my basic IP address. And since I am using a 4K monitor, I do want to choose here the quad 4K, so that the Ultra HD 4K, so that I have the correct aspect ratio for the monitor, not for what I think my projection is going to be. Now, this is going to be my first node. I'm going to go ahead and add this. There are some things I want to make sure that I have active, though. So I have my frustum and I have my space. These are good, so I'm going to go ahead and hit add. Now, here's my host. And here is my first node. And if I take a look at my node, I want to make sure that there are some settings that get adjusted. And one of those is the name of this. So node 0, typically, I would just rename this. into a node with a double zero, because if I have multiple nodes, you can have several working together. You generally want these to actually work that way. Since we're using a single frustum in here and a single node object, I'm just going to leave this one node in here, but I'm going to need multiple viewports. So here's my first viewport. This is actually my main wall. So I'm going to rename this as well. I'm going to call this one main wall. If I could spell, it would be really helpful. And we go VP, and that's my viewport. Now, this wall is going to need a different aspect ratio. Now, if you recall from our notes, my wall is going to use this mesh here. So I'm going to need to change my type in here from simple to mesh and choose the mesh that I'm using, which is my main wall. That's going to give me my projection. You can see that that's already projecting in my policy here. Now, what I also need to do is if I look at my projection in my output mapping, I need to change my region. So my region here is 3840 by 2160. This actually needs to be the 2112 by 13. Is that right? Is that no 1232? So that matches my pixels. That's my viewport. My viewport is actually going to be what's handling what's the wall in here. Now, right now, I'm just going to move this over to this side to lay this out. So as I move this over, you can see that this gives me my 1728 for my position. And that's basically the position inside my 4K pixel aspect ratio where the wall is located based on the position of what my width of my wall actually is. Now, I'm going to need a new viewport. I can do this a couple of different ways. I can either create and go up in here and add in a new viewport, or I can go to this viewport and just duplicate it by using Control D. If I duplicate it, I just need to rename it so I know what it is. And this is my side wall, or my wild wall. We'll call this wild wall. And I can just delete that VP right there, and that gives me an object. Now, they are on top of each other. So I'm going to move this right on over by zeroing that out. And I'm going to change the aspect ratios on this to the 416 by 416 that we have for this size. Now that's going to give me this wild wall. That's going to give me this actual spot. So it is a lot smaller than you're thinking. And I also need to change my mesh because right now it's projecting the same mesh policy. This, I need to choose my wild wall, and then I have both of these. So now if I look at my wall, my position is showing two different views. Make this a bit bigger so you all can see that. Now, what I did here is if I double click in my viewport, this will actually center and frame this so you can see everything that's in that viewer. Now you can see I've got my tiny spot, I've got my big spot. There are some other things that I want to check in here to make sure that these are actually working correctly before I transact to the wall. And that is I want to make sure that I might check my node and my viewports, everything, that I have some of my settings already turned on and off. One thing I forgot, if I jump back into my geometry, as you get started, I've already kind of set this already in my saving, but in my build settings, you want to go down here and make sure that you check on use full precision UVs. You need this for each of your meshes so that it actually projects exactly what your UVs are showing, and it shows up exactly what you've got in here. And I'm going to do the same thing for my wild wall. I'm going to go down in here. I'm going to go into my build settings and make sure that my useful precision UVs is set. Now, when you bring these in, sometimes they generate light map UVs. Light map UVs are if you're going to use this for DMX lighting or projection lighting or lighting inside the wall as well. You'll need to have that active, and it will also generate a new UV set as well. So once that's done, I'm saved, I'm ready to go. I have my geometry.
We have to save it, right?
Save,
Save this thing or not?
or yes, apply those. And I'm set. Go ahead and compile.
I mean,
And go ahead and save in here. So I have my viewports, I have my setting, and we're back in the engine. So now I have my configuration. Now my configuration needs to exist in its own level. I already have a streaming level that's already in here for my NDC, so if I wanted to add in a level, I would go ahead and do that. Now, if I look back in here, I already have a configuration that's loaded in. That's already projecting what I'm going to set for my policy, and that already lives in this level. So if I deselect here, right like that, and I show you what's being selected in these actors, I go ahead and make sure that I select my actors. and that's what's on this level. You want to make sure that your nDisplay configuration does live on a separate level, and that this level has a setting set so that it is always loaded instead of running it as a blueprint. When it comes up, it's typically going to run as a blueprint. You just want to make sure that that's already set. Now, once you're done in here, you make sure that you do a save. You make sure that you save all before you get ready to go. And you're going to want to make sure that you set up and run Switchboard. So when you go ready to launch, you're going to make sure that you have your Switchboard active, but you also want to generate a Switchboard listener. Now, the first time you do this, it's going to install Python. So as we do this, let's jump back to our slides really quick so I can just kind of show you what that looks like. It's not going to install Python because if I did that, everybody would lose all of their work and all that stuff, and it would kind of go back through and cause problems. Python's already installed. You're typically going to get this prompt, and it's going to run through you these steps. So you're going to verify your installation path, and you're going to move through your selection. And then your Switchboard listener, as it donates and goes through here, you're going to want to make sure that it puts one of these on your desktop, and you want to create a folder or keep a location so that you can easily locate and access each one of your listeners and your Switchboard configurations. For every version of the engine that you're going to be using, you're going to want to make sure that you have one of these that is available that you can have and access. Now, as we go through Switchboard, you are going to want to make sure that you actually create a Switchboard configuration and setting. So as you go through for this, your display configuration is going to be built with setting this up. So your configuration considerations in here is you want to make sure, are you working at home or are you working on a stage? If you're working at home, you don't have to worry too much about this. If you're working on a stage, typically you're going to be connected through Perforce or some other version control. So you want to make sure that you have your Perforce active when you do that, and then get that set up. Now, we already walked through an nDisplay configuration. There is one thing I want to talk about really quickly. When you're importing your mesh, right up in here, here's some helpful notes for your nDisplay configuration for importing. So as you import, make sure that you're aware that you're going to force front axis. You convert your scene units, and be aware that Unreal Engine does convert all that nice quad topology into triangles. So if you have curved geometry, just be aware that you're going to get a little bit of quad decimation. Now, as we walk through, we did show all of this, so I'm just going to kind of blow through these really quickly. We went through all of our steps, created our asset, showed our configuration. One thing I didn't point out in our configuration, if you are using a single node, you don't need to have your Ethernet connection in here. So you would disable that if you're at home so that your render sync policy changes to none. Since I am using a single node for this projection, I should have that set to none. But since we're using a multi-node system, you can keep that as Ethernet so it connects to all the nodes connected to the network. You will need a network connection if you are going to do multi-node processing. As I said, my layout works just like this. It looks as it's laid out for that. And this is why we lay that out in our nDisplay configuration. Our pixel mapping and our layout for our feed does present our one-to-one for our wall as it moves all the way through here onto this. And I'm gesturing, and you guys can't see what I'm gesturing at, the LED wall that you're seeing. All right, so there are some best practices to consider here as well. Again, we talked about making sure that you have a sub-level, that it's always loaded, and that your nDisplay configuration for your stage also exists in there as well. Also for organization, if we look at Unreal Engine, I do also recommend creating a stages folder so that if you have multiple configurations for multiple projects and multiple shows, those are all organized within that stages folder. Now, let's go ahead and go through our Switchboard configuration. There are some things I want to show here back in Unreal. And what I'm actually going to do is I'm going to switch on over to my nDisplay. So this is Switchboard. This is our Switchboard location. That's pretty big. Right when we're ready to go, typically I can close out of Unreal Engine once I've saved everything, because an instance of Unreal Engine is going to launch using Switchboard. Now, your settings, your configurations, you can create a new configuration in here. I have a configuration already loaded in here. This is my configuration, and my level that I'm choosing is my assembly. So typically with my assembly, I do want to make sure that I'm choosing my level as well, so that any nDisplay level that is chosen is where my level is working from. Now, as I go ahead and make this active, you're going to see that I've got an IP address, I've got an editor node, and I've got my other node here as well. I've also got a multi-user setting. Now my multi-user session is going to be iterative, and if I use this nice little plus button, this is going to allow me to iterate before I join, and it's going to allow me to generate this. Now, it is recommended that anytime you make any changes, you do iterate on your multi-user session so that you can connect correctly and have this connect and work correctly. Now, once I'm ready to go, there are some settings that we need to be aware of. So you're going to open up this nice settings menu, and hopefully you can see all of this, but there are some things you need to check. Make sure that your configuration path does match the configuration that you're actually working from. So if I'm looking through here and looking at my configuration, these do need to have that path. Your IP addresses, they need to be matching as well. And then if we go ahead and hit nDisplay, we want to scroll on down through here, make sure that your GPUs get changed. If you're using Perforce, you do want to make sure that you change the U project path. When you're using Perforce or any kind of version control, it is going to go to your control locations U path. You want to make sure that you have a copy of every project that you work on every render node and your control node at the same time so that those talk to each other for multi-user sessions. You will need to change your U project path for your render nodes to match the pathing location for the location of your project inside the actual render node. So you're going to see basically calling this render, and then one is editor. I typically prefer to call these control and render so you know which nodes are which, and you'll just change that. So when I name these, I typically call it control CTRL and render RNDR. That way I know which one is which, and I can just change that pathing so that it's at my render node. Now my Unreal path, this down here at the bottom is going to be my editor node. This is my control node. You should see that path. You shouldn't have to change this, but you may have to change your number of processors. If you have multiple GPUs, if you're using a single GPU like we are today, you want to make sure that your GPU is set to use just the one GPU. Now, once we are set up and we are ready to go with all of this, you can go ahead and close this out, but I do want to go back to my all to show my project settings for my multi-user. Now, if you're using single nodes, you do want to make sure that you turn off this multi-user launch in UI mode because you're not really going to need the UI version right now, but if you are on the stage, you typically want to make sure that your UI mode is enabled. You want to make sure that your viewports and everything else is in here and that the user's server name matches what we've got down here, plus or minus the configuration. If you iterate, you also want to make sure that you start with like 0, 0 numbers so that those are for better frame padding. But typically during each day, we put our dates on here and we go through each session. Since this is just one session, we're good to go. We are ready to go. Auto join is already enabled. I can close these down and I'm ready to go through and connect to the wall. So what I'm going to do right now is I'm going to close out of Unreal Engine and I'm going to go ahead and switch over and we're going to launch. So showing that we built everything correctly and everything is assembled correctly, we go ahead and hit this launch button. Everything collapses down. You're going to see Unreal Engine start to pop up. And once that happens, Unreal Engine will turn itself back on, create that control instance, and now we should be able to see everything on the wall. And we should be able to show on both walls. This in the wild?
Yeah.
Great. So as soon as this is up, this will show you everything. You can kind of see this is our environment. It's kind of load in. My actors can be on this stage, and you can see I got both walls working on my presentation and my configuration. And as we move around here, my Unreal Engine version came up in this wall. So I'm just going to move this back out of the way. And now we have that control. Now my control node can be controlled from another control user, and I'm using the word control a lot. But my controller can actively move and adjust these things. So if I wanted to select my viewport, if I'm connected to a multi-user session, as you can see, I'm still trying to join. It'll take a couple of minutes to join. Then I can actually move around, make adjustments, move plants, move objects, move buildings, add in other assets, and move those around in real time. So in order to do that correctly, I do need to have my multi-user session connected, and then that is how that actually works. So I've already transacted my project. I've got my listeners active. I didn't activate them to show you. How am I doing on time?
Good.
Okay. So we have, I think we're actually at time, aren't we? Okay. So, what?
They suggested maybe Q&A.
All right. So I know I went through here super fast. I'm going to stand back up and take over the mic. Thank you very much, Mike Stand, human bun. He did a great job. Round of applause for him. Hey, he had less feedback than me touching it. So as we go through here, I just want to really quickly, tomorrow we will have a slightly longer talk I know I just spoke a mile a minute, went through a lot of stuff to make up time, but this was just getting set up and working. As we go through all of this, tomorrow we will have a quick start for part 2, where Sean over here behind me is going to kind of take over, and he's going to walk you through some world building stuff, and he'll have a lot more time to actually work through that. Yeah, if there's any questions, anybody has any questions for me, I know that was a lot really quick, but feel free to ask. We have another mic, right, for people to have questions? Or you can come right over and ask me
Microphone
directly.
number 2.
I'll be around
we
on the
have
floor and all over the place tomorrow.
Testing, 1, 2.
We also have an Epic booth upstairs
Mic
where
2.
I will be doing another pair of talks on
right,
animation and engine.
Kevin, I got a question for you.
Yes.
Here we go.
Hi, thank you for the presentation. I was just wondering about the OS system. Is it specifically Microsoft, or can you use it with any OS?
For Unreal Engine? Or for using this?
If I wanted to do virtual production through Unreal Engine using Perforce and anything else that you
So you can use Linux, you can use Windows, you can use, what is that? OS X? Apple? That one? Yeah. Mac? You're good to go. It's just a matter of getting everything set up and working. You might have a few issues with Linux. You might have a few more issues with OS X. But for the most part, yeah. Unreal Engine works on all of them. You should be able to work on all of them as well.
Excellent. Any other questions
Yeah.
real quick? One last question.
Your biggest limitations are graphics cards.
So
But-
NVIDIA.
One thing to point out is that we do have better, what is it? Is it Metal? Is that the name of the Mac? Yeah. So Metal support for that hardware is improving. You're going to see a really nice improvement very, very soon in our next version. So it's on our public roadmap. If you have any questions or if you're curious about that, you can kind of hunt down and see what new features are coming in 5.3 in a very short amount of time.